Hello students, in this video we are going to see a production and inventory application. It is coming under transportation and transshipment problems and it is there on page 283. Uh, so the case goes like this. Contois Carpets is a small manufacturer of carpeting for home and office installations. Production capacity, demand and production cost per square yard and inventory holding cost per square yard for next 4 quarters are shown in table which is below. So here if you see here, note that the production capacity, demand and production costs vary by quarter, whereas cost for carrying inventory from one quarter to next quarter is constant at $0.25 per yard. So if you see this table, quarter 1, 2, 3, 4 is there. Production capacity definitely can vary because number of days which are available in that quarter may vary, number of working days. Demand obviously can vary day wise, month, the quarter wise. Also, production costs may vary because many of these businesses are labor oriented, and in some quarters, labor are easily available at a lower cost. But in some quarters, it may be there are other options available with the labors. So it is very difficult to get the labors, and you have to really pay at a much higher rate to the labors who are coming to your factory. So because of that, the production cost will vary, dramatically from quarter to quarter per square yard. And but the inventory carrying cost will remain, constant because that is within the factory to warehouse or nearby storage place, movements and holding the inventory. Right. So Contois wants to determine how many yards of carpeting to manufacture each quarter to minimize the total production and inventory costs for the 4 quarter period. Now what we are going to do this is that we are going to represent this problem as a network problem. So here is the network representation of the problem. This is how the problem will be converted into a network problem. So on the left side you have production nodes, right? Three production nodes. On the right side you have three demand nodes. And if you see quarter 1 production, quarter 2 production, quarter 3 production, these are the maximum productions possibles. And then quarter 1 demand, quarter 2 demand and quarter 3 demand becomes the right side. And the links between the two gives you the actual production which are happening in that quarter, and these values represents the production cost per square yard happening there. So as usual we can do the variables. For example, this is 1 5, so we can write here x15 as your variable, which will represent the production which is happening in the first quarter. Whereas if you write here x56, right, x56 will be the inventory which you are carrying from first quarter to second quarter, right? So this into this will give you the inventory carrying cost, this into this will give you the production cost. So similarly you will write x26, x67 here, x37 here, and then x78 here and x48 here. So this is how you are going to declare your variables right in the beginning, right? These are the beginnings. You declare the variables, and then your constraints, you can clearly, you cannot exceed the production. X15 cannot exceed 600, x26 cannot exceed 300. So these are the production side constraints. So but here at the demand side, this is x15 which is coming in this node, x56 which is going out of the node. So 25 minus 56, x56 should be equal to 400. And as we do always in transportation, that demand has to be perfectly made, so we will use equal to sign here. Whereas in this quarter there will be X26 will be incoming, X56 will be incoming, X67 will be outgoing. So X26 plus X56 minus X67 should be equal to 500. So this is how we are going to do the constraints, and the entire cost where this first four elements are production cost, and the next three elements are your inventory carrying cost. So together will be the total cost which we want to minimize. So uh, the entire model looks like this, right? This is the formula which we are going to minimize, and these are your demand side, your production side constraints. These are your demand side constraints, and these are your non-negative constraints. So when you set up this problem into a solver and solve it, you will get this particular solution where total cost will be 5150, and this is what is going to be x15, x2637, and x48 will be the productions which you will do in these 4 quarters, and only in x56 you are going to carry the inventory, whereas x67 and x67 and x78 you will not get any inventory will be zero. So this is the final answer. Thank you.